Hello, ladies and gentlemen. As promised, I'm here to explain how to solve for the transformers. All right. If you recall, there were three different types of transformers mentioned. There are step-up transformers, there are step-down transformers, and there are isolation transformers. Isolation transformers are transformers that have a step ratio of 1:1. In other words, what you put in is what you get out. So there's no change from input to output. Step-up transformers increase voltage. Step-down transformers decrease voltage. In both cases, step up or step down, what we're specifically speaking of is the voltage. All right. So we're going to start off by looking at a step up transformer. Now, I know this is a step up transformer because the number of turns in the secondary compared to the number of turns in the primary is greater. There are more turns. In the primary, I have 45 turns. In the secondary, I have 90 turns. Okay? Remember, the primary is my input. The secondary is my output. So on my input, I've got 45 turns, output 90 turns. What that means is I'm going to have an increase in voltage. All right, so now that I have determined that this is a step-up transformer and I know that the voltage is going to increase, in order to increase voltage, I'm going to have to multiply it by some value. Well, that value is what we call the step ratio. So first of all, to get the step ratio, we're going to take the larger number of turns and divide it by the smaller number of turns. So in this case, 90 divided by 45 is 2. Now we're going to write that result over the larger number, and then over the smaller number will always go a 1. So I have a 1:2 ratio. Now what that means is for every one time the conductor is wrapped around the core in the primary, it's wrapped around the core 2 times in the secondary. So in other words, if I had 5 turns in the primary, I would have 10 in the secondary because it would be 2 times more than the turns in the primary. Okay, so now we've determined the step ratio. What I need to do now is take my voltage and multiply it by the step ratio. So I've got 10 volts times 2 gives me 20 volts. Okay, now you'll notice my power pi over here. Power measured in watts is equal to the current measured in amps times the voltage measured in volts. What I'm going to do is I'm going to find the available power in the primary first. 10 volts times 5 amps gives me 50 watts. Now, as you recall, power from primary to secondary does not change. So that means the power that I have available in the primary is also available in the secondary. So now, I've got the voltage in the secondary. What I need to do is determine how much current is in the secondary. Since power doesn't change and voltage is one of the factors by which we get the power, that means the current by default must change. So since the voltage went up, current has to go down. So let's see. What we're going to do is, using Watt's law, we're going to take the power measured in watts divided by the voltage measured in volts. 50 divided by 20 should be 2.5 amps. So there we have it. There is a step-up transformer. Okay, so now we've looked at a step-up transformer. Here's a step-down transformer. So how do you think I know that this is a step-down transformer? Well, that's a good question. I'm glad you asked. You see, in the secondary, I have fewer turns than I have in the primary. That means that the number of turns has decreased. Since the number of turns have decreased, the amount of voltage is also going to decrease. So that's what makes this a step-down transformer. And as I said, with it being a step-down transformer, voltage is going to decrease. So for increase, we multiplied. Since we're going to decrease voltage, we're going to divide. Now, what are we going to divide by? Again, we're going to divide by the step ratio. So the first thing we're going to do after we've determined the type of transformer it is we're going to find the step ratio. And again, to do that, we're going to take the larger number of turns and divide it by the smaller number of turns. So again, 90 divided by 45 is 2. Once again, that result goes over the larger number, and the 1 goes over the smaller number. So now I have a 2-to-1 ratio. And what that simply means is for every 2 times the conductor is wrapped around the core in the primary, it's only wrapped around 1 time in the secondary. It also means that my voltage is going to reduce by a factor of 2. In other words, it's going to reduce 2 times. So I've got 20 volts. I'm going to divide that by 2 since my voltage is going to decrease. 20 divided by 2 is 10 volts. Next thing I'm going to do to find current, I need to know how much power I have available. So I'm going to take the voltage measured in volts times the current measured in amps. 20 times 2.5 gives me 50 watts. Once again, I know that the power available in the primary has to also be available in the secondary. So I have 50 watts of power available in the secondary. Now that I know the power, I know the voltage, I can find the current using Watt's law. Power measured in watts divided by voltage measured in volts gives me the current measured in amps. So 50 divided by 10 is 5 amps. And there we have it. That's how we work a step-down transformer. Okay, so we've looked at a step-up transformer and a step-down transformer. We're going to take another look at a step-up transformer, but if you'll notice, this time I have a variable that's missing. This time I'm given the power and I'm given the current. So how are we going to solve this one? Well, first of all, as I said, this is a step-up transformer, which means my voltage, whatever that is going to increase. Now that I know it's a step-up transformer, I know my voltage is going to increase. I'm going to find the step ratio. To do that, again, I'm going to take the larger number of turns and divide it by the smaller number of turns. 90 divided by 45 gives me 2, and the 1 goes over the smaller number. I have a 1-to-2 step ratio. Remember, that means that for every 1 time the conductor is wrapped around the core in the primary, it's wrapped around twice in the secondary. That 2 is also what I'm going to multiply the voltage by. But again, notice I don't have a voltage. So how am I going to do this? Well, what I'm going to do is I'm going to take the power measured in watts and divide it by the current measured in amps, because if I do that, this says that will give me the voltage. 50 watts divided by 5 amps is 10 volts. Now that I have the voltage, I work it just like normal. 10 volts times 2 gives me 20 volts. I know the power already, it's 50 watts, so to find the current, I'm going to take the 50 watts divided by the 20 volts, and that's going to give me 2.5 amps. Okay, so we just looked at a step-up transformer with a missing voltage. Now, I have a step-down transformer here, and I know that once again because there are less turns in the secondary than there are in the primary. But this time, instead of a missing voltage, I have a missing current. Okay? Now, this being a step-down transformer, what's going to happen? Yes, the voltage is going to decrease. Now, I know what kind of transformer it is. I know what's going to happen. What do we do next? Find the step ratio. And again, to do that, we take the larger number of turns and divide it by the smaller number of turns. So 90 divided by 45 is 2. Once again, The 1 goes over the smaller number. I have a 2-to-1 ratio. Now, notice, again, I have no current here. Do I need to find the current? Not really. And here's why. It's the voltage that we're changing first, right? So since I have the voltage, let's go ahead and work out what we got in the secondary. 20 volts divided by 2, since this is a step-down transformer, gives me 10 volts. Now I'm working it the same way that I've done everything else. I'm going to take the power divided by the voltage. 50 divided by 10 gives me 5 amps. So I really didn't need to find the current in the primary because working it the same way, I was able to find it in the secondary, no problem. So there you have it, folks. That's how we solved the transformers. Hope you found this video enjoyable and informative.